Ladies and gentlemen, children of all ages, welcome to the special right triangles video. We need to learn about the 45, 45, 90, and the 30, 60, 90 right triangles. Yes, I know you should know this already from geometry, but we're going to review it. So we know that in a 45, 45, 90 right triangle that the two sides called the legs, which are attached to the right angle, are congruent. They're the same size. So whatever they are, I don't really care. I'm going to call them both x. But the relationship we find when we use the Pythagorean theorem is that this is x times the square root of 2. If you want to prove it to yourself, you can do x squared plus x squared. We'll call it c squared. That would be 2x squared equals c squared. And we all know that in order to get c by itself, we have to take the square root, which would get us c on the right side. But then we would have the square root of x squared is x, and the square root of 2 can't do anything with that. So there we go. We've got the side we call the hypotenuse, and that is right there, x square root 2. So like for instance, if this was a 5 and this was a 5, this would be 5 radical 2. It's a pretty simple relationship. When you take the SAT, they'll actually have these relationships right at the beginning of every math test, so you can refer back to them, and they do come in handy for different problems. So make sure you refer back to them if you're taking the PSAT or the SAT. Alright, so the 30, 60, 91 is the more difficult one. It's not real terribly challenging, but everything hinges on you knowing the short leg. So there's a short leg, a long leg, and a hypotenuse. And everything has a relationship to this short leg. For instance, the hypotenuse is twice as long. The hypotenuse will be twice as long as the short leg. The difficult one is the long leg. The long leg is also a multiple of the short leg x, but it is x times the square root of 3. So we're going to use these relationships to, if you want to go through the process of double checking that, we can. So we have the short leg squared plus the long leg squared, that's x radical 3 squared, equals 2x quantity squared. So we have 1x squared plus radical 3 times itself is 3. X times itself is x squared, so that's 3x squared. And over here, 2 squared is 2x squared, 4x squared. And that's true because 1x squared plus 3x squared is 4x squared. So it does work out. That is a true statement, if you wanted the proof, which I'm sure many of you did, because you were questioning everything I said. I understand. I know all about you people. Well, so suppose I'm dealing with a situation in which I have a 45, 45, 90 right triangle. And I know that this side is 3, and I ask you what's x and what's y. And I say find x and y. It should not take you that long to figure out that x has to be the same and y has to be 3 radical 2. Because I'm just using the pattern. So for instance, the more difficult 45, 45, 90 right triangle question would be if you gave me something like the hypotenuse and you asked me for the side length. That's the one that's more challenging, because if I had to multiply to get to the value y here, took the 3 and I multiplied by radical 2, what would I do to go backwards? I would divide by radical 2. So x is 8 divided by radical 2. Now, you and I both know that the math teachers want you to rationalize the denominator and simplify as much as possible. So let me remind you about rationalizing. We multiply the top and the bottom by the same thing you see in that denominator, square root 2. Because what that gets me is the square root of 4, and we all know the square root of 4 is the nice whole number 2. In other words, these radicals pretty much canceled each other out, giving me the 2. On the top, I have 8 times the square root of 2. And now I need to think about the parts on the outside of the radical canceling. You cannot, let me remind you, you cannot cancel with something on the inside of the radical with something on the outside of the radical. But with these are both on the outsides of the radical, so they can be canceled out because right up here is multiplication. And so I would never do this if I had 8 plus radical 2 over 2. I would never try this trick because of the addition. Okay? So I would never try what I'm about ready to do with this. So 8 divided by 2 is 4, so my final answer for x is 4 radical 2. What do you think about y? Well, hopefully you've already thought about it and said, well, it has to be the same as the other side because they're both legs of a 45, 45, 90 right triangle. So it also has to be 4 radical 2. And honestly, the 45, 45, 90 is the easier one to deal with. So let me try the other one, the 30, 60, 90. So I've got the 30, 60, 90. And obviously that's the 60 and that's the 30. So this is 4. And I want to know x and y. So the hypotenuse is the easy one to figure out, right? Because that's 2 times the short leg, which is 8. But the long leg isn't all that difficult because it's the short leg times the square root of 3. So obviously this question was an easy one. So what happens when it's maybe not so easy? What happens if I start with 6 as the hypotenuse and I want to go backwards? I want to find x and y. What are they ringing the bell for now?
Leela Seaman, if you're in the building, please come to the main office at the 12 building.
Sorry, a little commercial break there for you. I know you enjoyed that. You're probably laughing hysterically at me. Okay, so x is equal to 6 over what? If you doubled it to go this way, then what do you do to go backwards? Of course, you're going to cut it in half, right? You're going to divide by 2, giving me an x value of 3. But once I know the short leg is 3, just like over here where we took 4 and we multiplied by radical 3 to get the long leg, we're going to do the same thing. To find y, we're going to take the short leg and multiply by radical 3. So here we have x and here we have y. Not too terribly difficult. What about... Oh yeah, this was the 60 and this was the 30, if you were wondering. What about if we had the long leg and we wanted to know the short leg and the hypotenuse? Okay, this is probably the toughest one of all of them. What we did to go from here to here, according to the original one, was we multiplied by radical 3. So to go backwards, we would divide by radical 3. Okay, so here we are. We're starting with the 10, and we're going back to x. So x is going to be 10 divided by radical 3. What